Never a bad idea to throw on your gloves before you flip the switch. Hey folks, welcome back to the channel. For those of you that are new, my name is Luke, and today we're going to be doing something a little bit different. Should be a quick episode, but we're going to be taking as much of a deep dive as we can into your AC monitoring meter. It can simultaneously monitor AC current and voltage. There's another model that's rated for DC. Should be a very similar kind of setup. And then we're just going to go over the parameters for you so you know exactly what you're looking at and what it all means. And hopefully that helps some of you out. So let's get into it. All right, let's check out what we got going on. It is the type AC. It's the split CT unit. Model is 022. Pretty simple packaging. I really like these monitors. I have another set of monitors that are not quite this fancy, but they can be really handy. You would be surprised the applications that you can find for these inexpensive type monitors. Let's go over, we're going to go over setup, and then we're going to set up our own kind of demonstration to maybe help you figure out how to apply it to your own specific needs for AC voltage and current monitoring. This looks like our little coupling, and it is going to be directional, so that'll be important. And it says that it's rated for, let's see, 0 to 100 amps. I'm not quite sure what the rest of this information on here is trying to tell us. I imagine it's probably in the manual. I don't go through the manual or anything before I start filming because I want a really good idea of how intuitive a product is for the video, so I can give you initial impressions. I think the first thing you're going to want to try to understand is how you're going to wire up this circuit. That's our little coupling right there that we'll set up, that's directional, that we just looked at. And that's going to go over, notice how they don't have hot or neutral labeled here on the circuit. That's because this will be able to go over any current carrying conductor, which in our AC setup is going to be either your hot or your neutral, but not your ground, right? We typically in an AC circuit are going to have a 3-wire setup, a hot and a neutral on your ground. Your ground is for safety. Your hots and your neutrals are for carrying the actual current. We have the dimensions in case you're trying to wire it into like a little box. And then our voltage, these are our parameters, right? So 80 to 260 volts AC, rated power no more than 100 amps or 22,000 watts, 45 to 65 hertz, measuring accuracy 1.0 grade. Not familiar with that scaling. Let's try to wire it in, see how intuitive it can be. So whatever you're trying to monitor, you're going to have to kind of rig something up, because typically when we look at doing yeah, that's not going to work. When we use an amp clamp on like this side of the circuit from the outlet down, usually we would use like something like this called a line splitter, and this would separate a hot or a neutral, because when we use our typical power cord for a load, the hot and neutral are going to be in the same sheath. And so if you put this little guy like this onto whatever load you're trying to monitor the current for, that's just not going to work, because the magnetic fields produced by the hot and the neutral are changing directions constantly back and forth like this, and they're canceling each other out as they pass by each other. So we need to isolate either a hot or a neutral to put this little guy around so that we can monitor the current. Otherwise, if you hook this up to just this, you're going to get a current measurement of 0. And then you're going to be very confused as to what's going on there. And a line splitter, something like we would put here, and then we would plug our load in here, and then we would normally be able to put like an amp clamp, you know, something like this we could put around here to monitor, but we don't have that option available to us because this is not going to fit around your typical line splitter. So you're going to have to figure out your own way to do that. Let's take a look at, ooh, I like that it has these tabs here. So like if you're working with, you know, when I used to do a lot of custom wiring, we worked with a lot of like aluminum plate. I think it was like 1/8 inch aluminum plate, and you could cut that out to this very specific thing, and then you could pop it into a panel. We do have this nice little diagram here. It has our model and our range. The way that I'm interpreting this diagram is that this is going to be our voltage monitoring here, and we need to tap into our circuit somewhere in our circuit in parallel with it, and then this is going to be our little inductive clamp, and that's going to monitor the current. Notice it is AC specific, so you know, we're not given any kind of color code or polarity specific setup. Yeah, so let's just wire it in the best that we can. So that means I'm gonna need a little bit of wire, and then I'm just gonna keep, I wish there was some kind of direction, at least for this inductive clamp, because it is gonna be directional, which means if it's directional, the polarity of these leads, I imagine, is gonna be important. Put that off to the side for now. So I want you to imagine, you know, this is essentially like our breaker panel, goes to distribution. This is like the feed side from the street to our panel, and then from our panel to our outlet. And then from our outlet, we're going to have, this is, you know, we're doing our example from the wall outlet out. So I'm going to move this out of shot, but just know this is what's going off out of frame. But if you're going to be doing stuff like this, especially with AC voltage, you know, get some electrically insulated gloves that are rated for working with electricity. The first thing that on here, right, we're trying to tap in parallel for voltage. I'm assuming the display is like this, so why don't we try to tap it in this way? These little terminal blocks are great. I should have them in my Amazon store. They're really great for temporarily wiring little projects like this. And they're rated for a good amount of current too, I think. You know, 800 volts, 15 amps. And they have these little protective covers. We're going to hold off on this. We'll give this thing some voltage so it should come to life. And then obviously, you know, we want to make sure that we're in our parameters. So double check, like, okay, so I'm working on a 120 volt circuit. That's well within its range. You know, this is a 25 watt light bulb. So I'm well within the 100 amp current limit. It possibly might not be enough current to be picked up on our meter. So that's something else that we want to think about. And then our frequency is rated for 45 hertz to 65 hertz. And I know that I'm here in the US with a 60 hertz power supply, so I should be within my frequency range as well. Never a bad idea to throw on your gloves before you flip the switch, just in case you accidentally didn't wire something up properly. Okay, so our bulb is on. I'm going to move it just out of frame so that we can see our display better. And we can just see right off the bat, okay, we've got our voltage listed. We have amps, watt hours, watts. Our hertz is here. And our power factor, that's relevant to efficiency, and that can be really great for calculating different things. So that's awesome that that's included in here. And now we need to just hook up our inductive clamp to either a hot or a neutral. Okay, and based off of the data here, you know, let's just take a moment to think about it. Does it make sense? Well, we have a 25 watt light bulb and it's saying that it's drawing 26.2 watts. That to me is making sense and telling me that everything's probably wired up. That's a good like verification check. You could also do 120 times 0.218, and that should give you your wattage. Our watt hours, our power factor of 1, and our frequency. There you go. I think these little monitors are great, especially for educational purposes, but they're really good for experimental projects. And that way you're not constantly having to, bust out your meter and make a bunch of different measurements all of the time. You just have the information displayed to you all of the time, and then you can wire it directly into your project. So really great little gadget here. It's got a backlight in there. So if you have any questions, comments, or concerns, let me know, and I'll catch you on the next one.